Now let's take up questions from exercise 18, question number 1. It says 5358 multiplied by 51, right? So we'll apply the column method and we put 0 and 0 in the front, and then we start from the last column and we keep an eye on the options. Okay, why? I'll come to know in some time. Let's say first we take the last column, so 1 into 8 is 8. Then last two columns, so 1 into 5 plus 5 into 8, cross multiplication. 1 into 5 is 5 plus 5 into 8 is 40. 40 plus 5 is 45. So we have 5 here and 4 carry forward. Now if you look at the options, there are two options which are 58 in the end. So it's either A answer or B answer. Okay, let's go ahead. Now the next one. Let's take three columns. So 1 into 3 cross multiplication, 0 into 8 cross multiplication, and 5 into 5 multiplication within the column. So it is 3 plus 0 plus 25. So 3 plus 25 is 28, plus 4 is 32. So we have 2 in the third place, right? And carry forward is 3, 4 is already used. Then we take all 4 columns. Now after that, even if you don't solve, it's okay because all your options have 273 in the beginning. So our answer is first option, that is done, right? But let's complete it. Let's take the 4 columns. So it is 1 into 5 is 5, plus 0 into 8 is 0, 3 into 5 is 15, 0 into 5 is 0. So it is 15 plus 5, that is 20, plus 3, 23. So 2 carry forward, 3 is used. Then we take the 3 columns, 5 into 5 is 25, plus 0 plus 0. So 25 plus 2, 27. So 27 in the beginning. But our answer was done with only last 3 digits values. Our answer was A. Okay, so answer option A is the correct answer. Alright, now let's take question number 2. It says 12 cube into 64 divide by 432. Alright, let's see. So if you see 64 does not divide 432 directly, but no problem. If you divide, or if you open 12 cube, is 12 into 12 into 12 into 64 divided by 432. If you see, 432 is divisible by both 4 and 3, hence it is divisible by 12. So cancel by 1 12. So it will give us 12 3s are 36, and then 72, so 12 6 are, okay. Then again 12 3s are 36, and 3 cancels 12 4 times. So our answer will be 4 into 64, which is 256. Right, so this is a simple question of calculation only. Okay, let's move on to the third question. A third question is very interesting. It is 72519 into 9999. Now one way of doing this question is the column method, and because this is a specific number 9999, we will not use column method, we will use something else. Let's see. 72519 into this 9999 can be written as 10,000 minus 1. So it becomes 725190000 minus 72519. Alright, so 72519 into 10,000 and 72519 into 1, right, and subtract. So if you subtract, you get 10 minus 9 is 1, 9 minus 1 is 8, 9 minus 5 is 4, 9 minus 2 is 7. This 9 becomes 8 minus 7, that is 1, and this 1 remains 1, and then 5, and then 2, and then 7. So our answer to the question is 725117481, which is option number A. Alright. Now let's come to question number 4. Question number 4, it says question mark minus 19657 minus 33994 is equal to 9999. Alright. So let's say x is the value in place of question mark. So it is x minus 19657 minus 33994 is equal to 9999. Alright. So let's do one thing. Send both the negative values to the other side so that they add up to the right hand side. It becomes 9999 plus 19657 plus 33994 994. Right? Add all of them now. So if you add 9 plus 7, 16 plus 4, 20. So 0, 2 carry forward. 9 plus 6, 9 plus 5, 14 plus 9, 23 plus 2, 25. So 5 here. 2 carry forward. Then we have 9 plus 6, 15 plus 9, 24 plus 2, 26. So 6 here. Again 2 carry forward. Then last one, 9 plus 9, 18 plus 3, 21. 21 plus 2, 23. So we have 3 here. And we are left with carry forward 2. So 2 plus 1, 3 plus 3, 6. So the answer is 63650, which is again option number A. Alright. So these are simple questions of addition and subtraction. Let's take up next question, question number 5. It says question mark. Let's say x is the value of question mark. So x plus 3699 plus 1985 minus 2047 is equal to 31111. Alright, let's do one thing. Let's add these two here. So it becomes x plus 9 plus 5 is 14, 1 carry. 9 plus 8 is 17 plus 1, 18, 1 carry. 6 plus 9 is 15 plus 1, 16, 1 carry. 3 plus 1 is 4 and 1, 5, 5, 6, 8, 4. And this 2047 goes to the other side and gets added. So 31111 plus 2047. We will have 58 in the end, and 20 plus 311, that is 331. So 33158. So x will be equal to 33158 minus 5684. Now subtract it properly to get 8 minus 4 is 4. 5. 15 minus 8 is 7. This becomes 0. 10 minus 6 is 4. This becomes 2. 12 minus 5 is 7 and 2. So the answer is 27474. This is the final answer. Okay. Now let's take question number 6. It is 107 into 107 plus 93 into 93. Now if you remember, it is 107 square plus 93 square. Now how do we calculate 107 square and 93 square? We use the base method, base 100. This is difference plus 7. So plus 7 added to the number. So it gives us 114. That is the first part. And the second part will be square of the difference. So 7 square is 49. So this is the square of 107. Similarly 93, the difference from base 100 is minus 7. Subtract from the number. So 93 minus 7 will be 86. That is the first part of the answer. And then second part is the square of the difference. So 7 square is 49. So it is 11449 plus 8649. Now 49 plus 49 is 98, and 114 plus 86 would be 200. So 20098 is the answer. So the final answer is 20098. Now let's come to question number 7. It says 8597 minus question mark. So let's say it is x. 8597 minus x is equal to 7429 minus 4358. So let's do one thing. First do the calculation on the right hand side. It is 8597 minus x equal to 7429 minus 4358. Subtract. 9 minus 8 is 1. 12 minus 5 is 7. This 4 becomes 3 minus 3 is 0, and 7 minus 4 is 3. So it is 3071. Now x goes to the right hand side, 3071 comes to the left hand side. So we have 8597 minus 3071, that is equal to x. So the required value of x would be 7 minus 1 is 6, 9 minus 7 is 2, 5 minus 0 is 5, and 8 minus 3 is 5. So the final answer of the question would be 5526. Okay. Now question number 8. it says 1, 2, 3, 4, 5, 6, 7, 9 multiply by 72. Now in this question, because one of them is very small, one of them is very large, so we will apply the conventional method of multiplication, right? So just multiply the method using the method of convention, right? So first you multiply by 2, so you get 2 nines are 18, that is 8, 1 carry forward. Then 2 sevens are 14 and 1, 15. Then 2 6 are 12 plus 1 13, 2 5s are 10 plus 1 11, 2 4s are 8 plus 1 9, 2 3s are 6, 2 2s are 4, 2 1s are 2. Then you multiply by 7 and shift one place. So put 0 in the end and then multiply by 7. 7 nines are 63, so 6 carry forward. 7 sevens are is 49 plus 6 is 55, so 5 here, 5 carry forward. 7 6 are 42 plus 5 47, so 7 here, 4 carry forward. 7 5s are is 35 plus 4 is 39, so 9 here and 3 carry forward. 7 4s are 28, 7 4s are 28 plus 3, that is 31, so 3 carry forward. 7 3s are 21 plus 3 24, so 4 here, 2 carry forward. 7 2s are 14 plus 2, 7 2s are 14 plus 2 is 16, so 6 here, 1 carry forward. 7 1s are 7 and 1 8. Now if you add them carefully, 8 0 is 8, 5 and 3 is 8, 3 and 5 is 8, 7 and 1 is 8, 9 plus 9 is 18, 8 1 carry forward, 6 plus 1 7 plus 1 8, 4 plus 4 8, 2 plus 6 8 and 8. Now the tricky part is the number of 8s. So count how many 8s are there. 1 2 3 4 5 6 7 8 9. Now look at the options. The first option has 1 2 3 4 5 6 7 8 8s. Second option has 1 2 3 4 5 6 7 8 9. So the option B is the correct answer, right? So this was a slightly tricky question. Okay, now let's take question number 9. It says minus 84 into 29 plus 365, right? There is nothing much to do in this question. You simply multiply 84 and 29 separately. So we'll use column method for that. 84 into 29, 9 into 4 is 36, so 3 carry forward. 9 into 8 is 72 plus 2 into 4 is 8, that is 80 plus 3 83, 8 carry forward. Then 8 into 2 is 16 plus 8 24, so it is 2436. So we get minus 2436 plus 365. All right, or you can take, or you can let's say minus common, it is 2436 minus 365. Subtract it to get your final answer. So 6 minus 5 is 1, 13 minus 6 is 7, then it is 3 minus 3 is 0 and 2 with a minus sign. So 2071 is the final answer of the question. All right. Now let's take question number 10. It says 4500 into question mark, that is x, equal to 3375. So this is a simple question. X would be equal to 3375 divided by 4500. So what we can do is we can straight away divide by 25. If you divide by 25, it will come out to be, let's see, if you divide by 25, it will be 25 1s are 25, 8, 87, 3s are 12, 5s are. And here it will be 25 1s are 25 becomes 20, so 200, so it becomes 0 and sorry, no, it is 8. All right, and last in the end we'll have one more 0. Now 135 and 180 both are divisible by 45, right? So 45 3 times and 45 5 times. So we have 3 by 5. So the answer of the question would be 3 by 5. Okay, right? So x is equal to 3 by 5. The question mark is 3 by 5 in this question. Now let's look at question number 11. It says the difference between the local value and the face value of 7. in the numeral 3267514 all right. Now what is the meaning of face value and local value? Let's see. Face value means the value itself, right? And the local value means the local value, let's say multiplied by the power of 10. Now what does it mean? Let's see. Look at 9 here. The face value of 9 in this case is 9, and the local value is 9 again, because this is unit place. All right, so this is unit place. So here the face value is 9, whereas the local value is also 9. Look at this 4. Now this 4 face value is 4, whereas the local value is 40, because this is tens place. Similarly, if you look at this 1, the face value is 1, whereas the local value is 100, because this is hundreds place. If you look at this 5, face value is 5, whereas the local value is 5000. All right, you can check it. This is unit, tens, hundreds, and thousands place. Now let's say the 7, face value is 7, and the local value is according to the position. It has to be unit, tens, hundreds, thousands, 10,000. So the local value is 70,000. All right. The question is asking, find the difference between the local value and the face value of 7 in this numeral. So the answer has to be, the required difference is equal to 70,000 minus 7. So it is 69,993. That's the answer of the question. And I think it is the option number D. All right. So this is the answer of the question. So you just needed to know the definition of the face value and the local value. All right. Now let's consider question number 12. It says on dividing a number by 5, we get a remainder 3. We get 3 as a remainder. What will be the remainder when the square of this number is divided by 5? Now there is one way of doing this question. Let's consider any number which when divided by 5 leaves a remainder 3. Right? That will be, you can take 3 as that number, or 8 as that number, or 13 as that number, or 18 as that number. Any of such number when divided by 5, remainder will be 3. Let's consider any one of them. Let's consider 8. So if my number is n equal to 8, let's calculate n square now. So n square will be 8 square, and that is 64. The question is saying, or it is asking, what will be the remainder when square is divided by 5? So that means 64 divided by 5. Find the remainder. So the remainder will be directly equal to 4. I'm sure you have done remainder earlier. Or you can divide 64 by 5 and find the remainder. Also, you can take only the last digit. If you can take any other number, still the remainder would be same. Right? Now, this is a shortcut method. Now, what is the conventional method? Let's look at the conventional method. I hope you remember the definition of remainder was, if there is a number n and if it is divided by a divisor d, there will be some quotient and some remainder, and this was the relation between them, that n is equal to divisor into quotient plus remainder. Now here my number is such, whereas divisor is 5, quotient is q, and remainder is 3. Right? So this is my n. Now n square would be square of 5q plus 3. If you open this square, you will get 25q square plus 2 into 5 into 3. A plus b whole square we are applying. So a square is 25q square. 2ab will be 2 into 5 into 3, 30q plus 3 square will be 9. Now you see, so effectively n square has become, now we have 25q square plus 30q plus 9. Out of the first two, take 5 common. So you will have 5q square plus 6q and the whole thing plus 9. Right? So this is our new number, that is n square is 5 into 5q square plus 6q plus 9. Now as you can see, if you divide this number n square by 5, very clearly this whole first part will be divisible by 5. The only remainder that you will get, it from 9. And what will be the remainder when 9 is divided by 5? It will be 4. Right? I repeat, The first part of that n square is divisible by 5. So there will be no remainder from the first part. Whatever remainder you will get it from the second part, that is 9. So 9 divided by 5, remainder is 4. Okay. Now let's take the next question, question number 13. This is a very specific question. We have already seen earlier that a raised to the power n plus b raised to the power n is always divisible by a plus b only if n is equal to an odd number, right? Now here in this case, 47 to the power 43 plus 43 to the power 43. Now the powers are 43, which is an odd number. So this number will definitely be divisible by 47 plus 43, which is equal to 90k. K is just a multiple, just to show a multiple. Similarly, 47 to the power 47 plus 43 to the power 47. Once again, 47 is the power in both cases and 47 is an odd number. So this number is divisible by 47 plus 43, and let's consider some other multiple m. So it is 90m. So for sure, as you can see, 90k is the first number, 90m is the other number. Now whatever is the common factor, you can see what is the common factor between 90k and 90m. Very clearly we can see that the common factor is equal to 90. Alright, common factor is 90. Okay, but you needed to remember this rule, only then you could do this question. Now question number 14. This is a direct question. In a division sum, the divisor is 10 times the quotient and 5 times the remainder. First you write the rule that the number n is equal to divisor into quotient plus remainder. Right? The question says the divisor is 10 times the quotient and 5 times the remainder, and remainder is 46. So here is already given that remainder is 46. So first we find the divisor, which is 10 times the quotient and 5 times the remainder. Okay, so now let's write divisor is equal to 10 times the quotient and it is also equal to 5 times the remainder. Remainder is already given 46, so we get D, this is 5 into 46, which is 230. So we have divisor equal to 230. And 10 times quotient is also 230, hence quotient is equal to 23. So now we have all the values necessary, that is divisor 230, quotient is 23 and remainder 46. Now the question is, what is the dividend? Dividend is n, right? So that n is equal to D into Q plus R. So 230 into 23 plus R is 46. Now 230 into 23 will be, 23 square is 529. So 5290 plus 46. If you add, it will become 5336. Alright. So this is the answer of question number 14. Now question number 15. It says what smallest number must be added to 4456 so that the sum is completely divisible by 6. Now see, for a number to be divisible by 6, it has to be divisible by both 2 and 3. Now to be divisible by 2, it should be even number. Here the last digit is 6, so it is an even number, so it is divisible by 2. And should be divisible by 3 also. So for 3, add the digits. So 4 plus 4 is 8, 8 plus 5 is 13, 13 plus 6 is 19. 19 is not divisible by 3. Right? What do you add to 19 to make it divisible by 3? So nearest multiple of 3 to 19 is 21. So by adding 2, it will become 21. The sum of digits will become 21. So the number becomes 4458. Check. Is it divisible by 2? Yes. Is it divisible by 3? 4 plus 4 is 8. 8 plus 5 13. 13 plus 8 is 21. So 21 is divisible by 3. So this number becomes both divisible by 2 and 3. Hence it becomes divisible by 6. So the number added is 2. This is one shorter way of doing this question. Now the other way would be the conventional method. Divide 4456 by 6. Right? Let's see. 6 sevens are 42. So we have minus, so we have 2 remainder. Then we take 5, 6 4s are 24. So we have 1 remainder. Then 6 comes, 6 2s are 12. So we have 4 remainder. Now what do we add to 4 so that it becomes divisible by 6? So very clearly, if you add 2, it will become divisible by 6. So if you add 2, it becomes 6 and divisible by 6. Hence, the number required to be added is 2. This is the other method. Okay. So number added is 2. That is question number 15. Now let's take up question number 16. It says, what least number must be subtracted from 13601 so that the remainder is divisible by 87? Now here the divisor is large. So what do? We use conventional method directly. Okay. So 87 divide by 87, 13601. 87 ones are is 87. Subtract, you will get 36 plus 39, that is 49, then 0. Now 87 5 times is 435. So 435, again subtract. So it will give us 10 minus 5 is 5, 8 minus 3 is 5, 4 and 4 cancel. Then we get 1, 551. So now take it 6 times. 6 sevens are is 42. 4 carry forward, 6 eights are 48 and 4 is 52. So 522. If you subtract, you get 11 minus 2 is 9 and 4 minus 2 is 2. So 29 is the remainder. So what do we need to subtract from 13601? We need to subtract this 29 itself, right? If you subtract 29, then in this place of 29, we would have got 0 as the remainder. All right. That means to make 13601 divisible by 87, we need to subtract 29. So the number to be subtracted is equal to 29. Whatever is the remainder should be subtracted, as simple as that, right? Now let's take question number 70. It says, what will come in the place of question mark? So let's say the question mark is x. So we can write the question as square root of 86.49 plus square root of 5 plus x square equal to 12.3, right? Now from base method of 100, this 8649 looks like the square of a number which has, because it has 49 in the end, it looks like the number which has 7 difference from 100. Let's check it. Now also 8649 is below 10,000. So the number should be, or the square root of 8649 should be less than 100. So less than 100 with a difference of 7, it may be 93. So let's check 93 square. Now 93 from base 100, the difference is 7 and it is minus 7. So 93 minus 7 is 86. And 7 square will occupy the second part. So 7 square is 49. So 8649 is equal to 93 square. That means 86.49 will be the square of 9.3. Alright. So square root of 86.49 will be 9.3 plus square root of 5 plus x square is equal to 12.3. Okay, so that means 9.3 goes to the other side. We'll have root of 5 plus x square is equal to 12.3 minus 9.3. 12.3 minus 9.3 is equal to 3. So if you remove the square root, it will become 5 plus x square is equal to 3 square, which is 3 square is equal to 9. So x square is equal to 9 minus 5, which is equal to 4, which is 2 square. So finally, the answer would be x equal to 2. So x square is equal to 2 square, so x is equal to 2, right? Now here, it is also important to know another method to find square root, that is the division method, long division method. What do we do in that? Let's see. Write 86.49 and then make pairs of digits from the end. So 49 is one pair, 86 is one pair. Then check 86 is close to which square on the lower side. So 86, below 86, 81 is the square of 9. So we start with 9 here, 9 here, and 9 into 9, 9 square is 81, we write here, and then we subtract. I repeat, start pairing from the end. So 4, 9 is one pair, 6, 8 is the remaining pair. Then start from the beginning. 86 is one pair. Look at a number which is a square and below 86, that is 81. 81 is the square of 9. So write 9 here in the place of divisor and 9 here in the place of quotient. And then take square of 9 and subtract from the first pair. So 86 minus 81, that will give us 5. Now comes the decimal position. So decimal position will go on to the quotient position. Then every time in the normal division we take one digit. In the square root process we'll take pair of digits. So take 4, 9 below, right? Also, whatever we had multiplied earlier, add it to the divisor. So 9 plus 9 becomes 18. All right. Now comes the most important part. You have to place a digit after 18 here so that it becomes a 3-digit number. Now whatever you place here, you have to multiply by the same digit, right? And that multiplied to the whole number should come out to be close to 549. I repeat, you have to consider a digit. You have to put a digit after 18 here, okay? And whatever the number you get, say for example, if you put 2, so you have to multiply 182 to 2, right? Multiply 182 to 2, you will get 2 2s are 4, 2 8s are 16, 2 1s are 2 plus 1 3, 364. Is it close enough to 549? It is very less. So let's try 3. So put 3 after 18 and then multiply by 3. So 3 3s are 9, 3 8s are 40, 24, 3 1s are 3 plus 2 5, 549. This comes out to be 549. If we had taken let's say 184, then we had to multiply by 4 and this will definitely go above 549. Check it. 4 4s are 16, 1 carry, 4 8s are 32 plus 1 33, and 4 1s are 4 plus 3 736, right? So this is be above, this 364 is below, 549 is the exact value. So we put 3 here and multiply this number by 3 to get 549 and it will get 0 0. So it is a perfect square and the square root will be this number 9.3. This was the long division method. Okay, you can go back to one of the theory sessions where we have discussed long division method for square roots. Now question number 18, it says square root of, there is a big bracket, 12.1 whole square minus 8.1 whole square, bracket closed, divided by again bracket 0.25 square plus 0.25 into 19.95 and bracket closed. Now what do we do in this case? Now first we write in the proper division format. It is 12.1 square minus 8.1 square divided by 0.25 square plus 0.25 into 19.95. Alright. Now in the numerator you can see it is a square minus b square. So it can be factorized as a minus b into a plus b. Now 12.1 minus 8.1. So a minus b into a plus b will be 12.1 plus 8.1. Okay. Now in the denominator take 0.25, 0.25 common, and inside we will have 0.25 plus 19.95. Alright. Now simplify. 12.1 minus 8.1 will be 4 into 12.1 plus 8.1 will be 20.2 divided by 0.25 into 0.25 plus 19.95 would be equal to 20.2. So that means 20.2 is cancelled, and square root of 4 is 2, square root of 0.25 is 0.5. Alright. Now if you remove decimal, you will get 20 in the numerator and 5 in denominator. 5 cancels 20 4 times. So the final answer of the question is 4. Alright. So you just had to be careful about the process or the order of the process. Alright. Now question number 19. To solve question number 19, there are two ways. First, let's see. We know x plus y whole square. X plus y whole square would be equal to x square plus y square plus 2xy. Alright. Here it is given x and y, the values are given. In place of x, it is root 5 plus root 3 divided by root 5 minus root 3 plus root 5 minus root 3 divided by root 5 plus root 3. So we have put the values on the left hand side. On the right hand side, we keep x square plus y square as it is because we have to find it, plus 2 into x into y. Now you see, x into y will be 1. Why? Because x and y are reciprocal of each other. As you can see, x is root 5 plus root 3 divided by root 5 minus root 3 into y is root 5 minus root 3 divided by root 5 plus root 3. So it will be equal to 1. So hence 2xy term will be equal to 2. Now on the right hand side again, the whole thing is inside the whole square. Denominator will be LCM, root 5 minus root 3 into root 5 plus root 3. So root 5 minus root 3 into root 5 plus root 3. Whereas in denominator, it will be root 5 plus root 3 into root 5 plus root 3. So it will be root 5 plus root 3 whole square. Plus the other side, the other part will be root 5 minus root 3 into root 5 minus root 3. So it will be root 5 minus root 3 whole square. And on the right hand side, it will be x square plus y square plus 2. Now we again know that a plus b whole square is a square plus b square plus 2ab. So on the left hand side, we will have root 5 plus root 3 whole square is 5 plus 3 plus 2 root 5 root 3, it will become 2 root 15. Similarly, root 5 minus root 3 whole square will be 5 plus 3 minus 2 root 15. And in the denominator, a minus b into a plus b will become a square minus b square. So it is 5 minus 3. The other side is still x and the whole square. Do not forget. The other side is x square plus y square plus 2. Now this side, 2 root 15 will get cancelled and we will have 5 plus 3, 8, 5 plus 3, 8, 8 plus 8, 16 divided by 2. That is 16 divided by 2 whole square, which is equal to 8 square, which is equal to 64. This is right hand side is equal to x square. Sorry, this is left hand side. 64 is left hand side. Right hand side is x square plus y square plus 2. So from here we get x square plus y square equal to 64 minus 2, which is 62. This is one way of solving this question. Now let's take a look at another way, which is the direct conventional method. We are doing question number 19, that is other method. For question number 19, here it is given that x is equal to root 5 plus root 3 divided by root 5 minus root 3. We straight away calculate x square. So x square will be root 5 plus root 3 upon root 5 minus root 3 whole square. So if you open it, it will become root 5 plus root 3 whole square divided by root 5 minus root 3 whole square, which will be equal to 5 plus 3 plus 2 root 15 and 5 plus 3 minus 2 root 15. So we have x square is equal to 8 plus 2 root 15 and upon 8 minus 2 root 15. You can take out 2 common and cancel to get 4 minus root 15 upon 4 plus root 15 divided by 4 minus root 15. Alright. Similarly, you can calculate y square because y is given root 5 minus root 3 upon root 5 plus root 3. So you can calculate y square as root 5 minus root 3 upon root 5 plus root 3 whole square, which will come out to be root 5 minus root 3 whole square divided by root 5 plus root 3 whole square. If you open it, you will get 5 plus 3 minus 2 root 15 divided by 5 plus 3 plus 2 root 15. That will come out to be 8 minus 2 root 15 divided by 8 plus 2 root 15. Again, you can cancel 2 by taking out common from both numerator and denominator. You will get y square as 4 minus root 15 upon 4 plus root 15. And the question is asking the value of x square plus y square. So now we have x square from here and y square from here. Add them, right? And add and rationalize them. So it is x square plus y square is equal to 4 plus root 15 upon 4 minus root 15 plus 4 minus root 15 upon 4 plus root 15. Okay, so this will give us, in the denominator we will have 4 minus root 15 into 4 plus root 15, and in the numerator we will have 4 plus root 15 whole square on one side plus 4 minus root 15 whole square on the other side, right? So if you open the square, you will get 4 plus root 15 whole square will be 4 square plus 15 plus 2 into 4, that is 8 root 15, and the other part will be 4 square plus 15 minus 8 root 15. And in denominator you will have 4 minus root 15 into 4 plus root 15, that is 4 square minus 15. Okay. So from here 8 root 15 and 8 root 15 will get cancelled, and we will have 4 square is 16 plus 15, that is 31, and again 4 square plus 15 is 31. So 31 plus 31 is 62, and divide by 4 square minus 15, that is 1. So 16 minus 15 is 1. So we have final answer as 62 by 1, and hence 62 is the answer. Okay. Now let's take up question number 20. It says, what should come in the place of both the question marks in the equation? Assuming both the question marks are same and we put x in place of question marks, we get x upon root of 128 is equal to root of 162 upon x. Now cross multiply, so you will get x into x, that is x square, and the other side both the values are under root, so we can get root of 128 into 162. Now if you factorize, in fact if you just write 128 as 2 into 64 into 162 as 2 into 81. Why? Because both 64 and 81 are squares. So this x square becomes, look at this carefully, there are two 2's, so it is 2 square. 64 is 8 square, 81 is 9 square. So this is x square, right? So x square is equal to, now the other side root will go on, root will be removed. So if we can remove the square root sign, and we'll get 2 into 8 into 9. Now 2 into 8 is 16, 16 into 9 is 144, which is 12 square. So x square is 144, so x is equal to 12. So answer of the question is 12. Now let's take question number 21. It says, by how much does root 12 plus root 18 exceeds root 3 plus root 2? So basically what we need to do is find the difference between these two quantities. How? Root 12 plus root 18, that is one number, minus root 3 plus root 2. Now simplify this. root 12. 12 is 4 into 3, so it will be 2 root 3 plus 18 is 2 into 9, so it is 3 root 2 because 9 square root is 3, so 3 root 2 minus the other side is root 3 and minus root 2. Now 2 root 3 minus root 3 will be root 3. Similarly 3 root 2 minus root 2 will be 2 root 2. So the final answer of the question is root 3 plus 2 root 2. Alright, this is question 21. Now question 22. It says the greatest 4-digit perfect square number is. Now see, this is a very interesting question. The smallest 3-digit number is 100 and 100 square is 10,000. Now 10,000 is a 5-digit number. We need a number which is less than 10,000 because a 4-digit number will always be less than 10,000. Alright, let's go back to 100. Let's consider a number below 100. The immediate next number is 99. Calculate 99 square by the 100 base method. You'll get it like 99 minus 1 is 98 and square of 1 is 0 1. So you see, now you see 100 and 99, there is no number in between them. Now 100 square is 10,000, 99 square is 9801. So there will be no other perfect square between 10,000 and 9801. Hence 9801 is the largest 4-digit number and a perfect square. So this is our answer. Alright. Now let's take up the next question, question number 23. It says the difference of two numbers is 1365. Okay, so difference of two numbers, let's say the one number is larger number is A and the smaller number is B. So it is A minus B that is equal to 1365. Okay, and the second information says on dividing the larger number by the smaller, we get 6 as quotient and 15 as remainder. Now I hope you remember, when a number is divided by a divisor, there is some quotient Q and the remainder R. In this case, we are dividing the larger number, so the number is A, and we are dividing by the smaller number, so divisor is B, into the quotient is already given as 6 and the remainder is given as 15. So what we have is A is equal to 6B plus 15. So basically we have two equations and two unknowns A and B. Now in the first equation, put A equal to 6B plus 15. We already have A minus B equal to 1365. Put 6B plus 15 in place of A minus B is equal to 1365. Now 6B minus B is 5B. 15 goes to the other side. So 1365 minus 15 is 1350. So value of B will be 1350 by 5, that is 270. So value of B is 270, that is smaller number. Hence the larger number A would be B plus 1365, which is 270 plus 1365, which is equal to 13 and 2 15, 1635. Right? You can check it. 5 plus 0 is 5, 6 plus 7 is 13, 3. 3 plus 1, 4 plus 2, 6, 1635. In the question, it is asking the smaller number. So the smaller number is 270. Okay. Now, question 24, it says the difference between a positive proper fraction and its reciprocal is 9 by 20. Now, this is a very tricky question because a positive proper fraction will always be less than 1. A proper fraction is from minus 1 to 1, and out of that the positive number will be 0 to 1. So it is less than 1. Now its reciprocal will always be more than 1. Say for example, if I take a fraction 1 by 3, its reciprocal will be 3. Right? If I take a proper fraction as 1 by 5, its reciprocal will be 5 by 1. So if I take the positive proper fraction as x, its reciprocal will be 1 by x, where 1 by x will be more than 1 and x will be less than 1. And the question says the difference between them is 9 by 20. Now the larger one is 1 by x minus the smaller one, that is x, right? That is equal to 9 by 20. So we have to be careful about this. So it is LCM x, 1 minus x square, that is equal to 9 by 20. Cross multiply to get 20 minus 20x square is equal to 9x. Take everything to the right side, we'll get 0 is equal to 20x square plus 9x minus 20. Now if you factorize, 20 to 20 is 400 and 25 into 16 is also 400. So we will have 20x square plus 25x minus 16x minus 20 equal to 0. Now here we'll have 4x common, so we'll get we'll have to take 5x common. So we'll have 5x common, and inside we have 4x plus 5. Similarly, from the other two we'll have minus 4 common, so we'll have 4x plus 5 equal to 0. So we will get 4x plus 5 common into 5x minus 4. Now if you equate each factor to be 0, you will get x equal to either minus 5 by 4 or 4 by 5. So we don't have to take the negative number. The question is saying the positive fraction. So positive fraction would be 4 by 5. Ignore the negative one. 4 by 5 is the answer of this question. Alright. In this question you have to be careful about which one is the larger one. The larger one would be 1 by x. Alright. Now question 25, it says, if n is a natural number, then 6n square plus 6n is always divisible by, let's see, it is 6n square plus 6n. If you take out 6n common, you will get n plus 1. Now it looks like 6 into n plus 1. Now please understand that n and n plus 1 are consecutive integers. So that means one of them will be even number, the other one will be odd number. Now odd number can be divisible by anything, so we can't be sure about anything. But the even number is definitely going to be divisible by 2. That means this whole thing is always going to be a multiple of 6 into 2. Hence it is always a multiple of 12. Right? That's the maximum that we can say. Okay, so the answer of the question is 12. It is definitely divisible by 12. Now the other way of doing the same question would be put some values for n. For example, if I put n equal to 1, then 6 into 1 square plus 6 into 1 would be equal to 6 plus 6, that is 12. If you put n equal to 2, you will get 6 into 2 square plus 6 into 2, which will come out to be 4 into 6, 24 plus 12, that is 36. If you put n equal to 3, you will get 6 into 3 square plus 6 into 3, and that will give us 9 into 6, 54 plus 18, that is 72. Right? If you get n equal to 4, and similarly by checking 3, 4 values, I think that's sufficient to see that it is divisible always by 12. Now this one is 16 into 6, 96 plus 24, that is 120. Now the outcomes, if you look at the outcomes, 12, 36, 72, 120, all of them are definitely divisible by 12. So the answer of the question is 12. Alright, so there are two ways of doing this question. Now the next couple of questions are based on direct definitions. Question 26, it says the sum of first 5 prime numbers. Now the first 5 prime numbers are 2, then 3, then 5, then 7, and then 11. Just add them to get your answer. So 2 plus 3, 5, 5 plus 5, 10, 10 plus 7, 17, plus 11, that is 28. That's it. Then we have question number 27. It says the largest 3-digit prime number is. Now the first 3-digit number is 100. We know it is not a prime number because it is divisible by 2 and 5. So this cannot be the answer. The next one is 101. Now 101 is not divisible by anything. You can check it. I hope you remember the method of checking the prime number, that is square root. Take the square root of that number, 101, that is approximately equal to 10. Consider all prime numbers below 10, that is 2, 3, 5 and 7. Check 101, is it divisible by 2? No. Is it divisible by 3? No. Is it divisible by 5? No. Is it divisible by 7? No. Now if the given number is not divisible by any one of them, hence it is a prime number. So 101 is the first 3-digit prime number. Alright, so answer of this question would be none of these. Okay, just be careful about this. 28th question, it is a direct question. It says the smallest prime number is. Now remember, 1 is neither prime nor composite. Smallest prime number is 2, and 2 is the smallest prime number, as well as it is the only even prime number. Only even prime number. Okay. So this is what we have in question number 28. Now question number 29. It says which is a prime number. Now I hope you remember the method. The same method will be repeated. Numbers are 299, 300, 301 and none of these. Now 300 is not a prime number, that we know for sure. Let's start checking for 299 and 301. Let's see. 299. What is the square root of 299? Approximate square root of 299 is 17. Take or consider all the 17 square is 289 and 18 square is 324. So square root of 299 is approximately 17 point something. So we have to consider all prime numbers below 17. So 2, 3, 5, 7, 11, 13 and 17 itself. Is it divisible by 2? Is 299 divisible by 2? No. Is 299 divisible by 3? 9 plus 9, 18 plus 2, 20. No. Is 299 divisible by 5? No, it should have 0 and 5. Is it divisible by 7? Divide by 7. So 7 4s are 28. Remainder is 1. 19 is not divisible by 7. Is it divisible by 11? 11 2s are 22. 79, not divisible by 11. Is it divisible by 13? 13 2s are 26. Then 3, 39. 13 3s are 39. Oh, so it is divisible by 13. So 299 is not prime, right? Because it is divisible by 13. 299 is equal to 13 into 23. So this is not a prime number. Now the next number that we have is 301. Take the square root of 301, that is still approximately 17 point something. So consider the prime numbers 2, 3, 5, 7, 11, 13 and 17. Is it divisible by 2? 301? No. Is it divisible by 3? No. Is it divisible by 5? No. What about 7? 7 4s are 28. So 2 and 1. 21, 7 3s are 21. So we are doing normal division. So this 301 is divisible by 7. So 301 also is not prime number. Alright. So you can check 301 is equal to 7 into 43. So even 301 is not a prime number. Alright. So the answer is none of the given options. So none of these. Question is asking which is prime number. So answer is none of these. Okay. Now question number 30. It says which is co-prime. Now co-prime is always a pair of numbers in which there is no common factor, or common factor is 1, or HCF is 1. Now first option is 11 and 12, very clearly their HCF is 1. Similarly second option 15 and 16, their HCF is also 1. You can calculate the HCF, you can see the common factor. C, here both the numbers are themselves prime, 13 and 17, so HCF is automatically 1. And now fourth option is all of the above. So answer of the question would be all of the above. So this question is all of the above. This is the answer. Okay. Now next question, question number 31. It says if the number 517 star 324 is divisible by 3, then what should be the digit in place of star? Now we know that the divisibility test of 3 is checking the sum of digits. So check the sum of digits. The sum of digits would be equal to 5 plus 1 plus 7 plus star plus 3 plus 2 plus 4. So add all the other digits. 5 plus 1, 6 plus 7, 13 plus 3, 16 plus 2, 18 plus 4, 22 plus the star value. Now this 22 plus star value should be divisible by 3, right? Now for the smallest number, the nearest multiple of 3 to 22 is 24. Hence the value of star is 2. 24 minus 22, that is 2. So the smallest number in place of star should be 2. I repeat, sum of digits, sum of the other digits is 5 plus 1, 6 plus 7, 13 plus 3, 16 plus 2, 18 plus 4, 22. Plus star, that is the total sum of digits. That should be divisible by 3 because that is the divisibility method, test method of 3. Nearest multiple of 3 to 22 is 24. So 22 plus star should be 24. So the value of star has to be 2. Alright. Similarly, we can take question number 32. It says, if the number 481 star 673 is divisible by 9, right? So same process, even for 9 we have the same method, that the sum of digits should be divisible by 9. Add all the other digits. So the sum would be equal to 4 plus 8 12 plus 1 13 plus 6 19 plus 7 26 plus 3 29 plus the star. Now above 29 the nearest multiple of 9 is 36. So 29 plus star should be equal to 36 for the star value to be smallest. So the star value is equal to 36 minus 29, and that is 7. So the value of star has to be 7 in this question. Alright. Now question number 33. It says 9721 star and 6 is completely divisible by 11. Now remember, what is the divisibility method for 11? We add all the digits at odd places. Then we add all the digits at even places, and then we take the difference. Let's say the sum of digits at odd places, that will be 9 plus 2 plus 5 plus 6. So I'll write everything, 9 plus 2 plus 5 plus 6 minus 7 plus 1 plus star. This difference should be divisible by 11, or it may be 0 also. Let's see. 9 plus 2 is 11. 11 plus 5 is 16 plus 6, 22. So 22 minus 7 plus 1 is 8 plus star. So if you open, it will be 22 minus 8 minus star. Now 22 minus 8 is 14. So it has to be 14 minus star. Now this number should be either 0 or divisible by 11. So let's see. It may be equal to either 0 or 11 or further. It can't go further because 14 minus something has to be less than 14, right? Similarly, it can't go in negative because for this to be negative, star would be more than 14, which is not possible because star is a single digit number. And also the question is asking for smallest value of star, right? So in that case, if you take 0, star will be equal to 14, which is not possible. If you take 11, so 14 minus star is equal to 11, it will give you star value to be 14 minus 11, that is 3. So the value of star has to be 3 in this case. Alright. So answer is 3. Now let's consider question number 34. In question number 34, it says 5 star 2 is divisible by 6. Now 6 is 2 into 3. So the number should be divisible by both 2 and 3. Now for the number to be divisible by 2, the last digit has to be even. Here the last digit is 2, which is even. So it is divisible by 2. Now the only thing that we need to check whether this number is divisible by 3 or not. And for 3 we need to check sum of digits. So sum of digits will be 5 plus star plus 2, that is 7 plus star. Now this should be divisible by 3. Now the nearest multiple to 3 above 7 is equal to 9. So the value of star has to be 2. Right? So it has to, the number is 522. Then only it will be divisible by 6. So star value is 2. Let's take question number 35. In question number 35, it says 3765 star 2 is divisible by 8. Now, remember what is the divisibility test for 8? It says the last 3 digits. So that means 5 star 2 has to be divisible by 8, right? So it is a number above 500 and it has to be divisible by 8. Let's check. If you see, this is the possibilities are 502, 512, 522, 532, 542, 552, 562, 572, 582 and 592. I hope you can see that 502 is not divisible by 8. 512 is divisible by 8. Alright, because it is 8 cube. 522 divided by 8. You can see that 522 is not divisible by 8. 8 6 are 48. So it will be remaining 4. 42 is not divisible by 8. 532 is not divisible by 8 because it is 500 plus 32. 500 is not divisible by 8. 32 is divisible by 8. So this number is not divisible by 8. Similarly, 542, you can check. It is 502 plus 40. 40 is divisible by 8. 502 we have already checked, it is not divisible by 8. Now 552, this will be divisible by 8 because it is 512 plus 40, right? So 40 is divisible by 8, 512 is divisible by 8, or you can divide by checking it. Or you can also see it is 560 minus 8. So this is also divisible by 8. 562, it is not divisible by 8 because it is 560 plus 2. 572 is 500 plus 72. 500 is not divisible, 72 is divisible. So 572 is not divisible. 582, 560 plus 22 is not divisible by 8. 592, it is 560 plus 32. This is also divisible by 8. So there are three numbers which are divisible by 8. 512, 552 and 592. That means the star value can be either 1 or 5 or 9. Here in the options, we can see that only 5 is there. So answer of our question is 5. Right? Now, the next question, question number 36. It says 476 star, so there are two stars and 0 is divisible by both 3 and 33. So they are divisible by both 3 and 11, sorry. They are divisible by both 3 and 11. The non-zero digits in the hundreds and tens places are respectively. Now in this question, instead of solving, you put the values and check. Let's say if you take the first option as 7 and 4, you put in place of star. So 476, 740 and check whether it is divisible by 3 or not. So 4 plus 7 is 11, 11 plus 6 is 17, plus 7 is 24, plus 4 is 28. This number is not divisible by 3. So this option is itself wrong. Here itself is wrong. Question. Then let's take option B. It says 7 and 5. Put it in the places of star. 476, 750. Check whether it is divisible by 3 or not. 4 plus 7 is 11 plus 6 is 17 plus 7. 24 plus 5, 29. Is it divisible by 3? No, it is not divisible by 3. So there is no need to check for 11 also. Then let's see C option, that is 8 and 5. Put in places of star. 476, 850. Check the sum. 4 plus 7, 11 plus 6, 17 plus 8, 25 plus 5, 30. 30 is divisible by 3. Alright. Then if it is divisible by 3, you need to check whether it is divisible by 11 or not. Let's see. 4 plus 6, 10 plus 5, 15. So 15 minus 7 plus 8, 15 plus 0, 15. So 15 minus 15 is 0. So this the outcome is 0, hence it is also divisible by 11. So option C gives us a number which is divisible by both 3 and 11. Hence the answer is C. Alright. So this method of putting the options back into the number is a very good method which could have been used in previous questions also. Right? Here, because the method was going to be longer for both 3 and 11, we opted for this particular method. You have to decide on the basis of situation. Now, question number 37. It says, which of the following is divisible by 11? There is no other way. We have to check every option. So let's say first option, it is 2, 3, 5, 6, 4, 1. 2 plus 5, 7 plus 4, 11. 3 plus 6, 9 plus 1, 10. So 11 minus 10 is 1. Hence it is not divisible by 11. To be divisible by 11, the outcome should have been either 0 or a multiple of 11. Let's say B option. It is 2, 4, 5, 6, 4, 2. Check the sum of digits at odd places. 2 plus 5, 7 plus 4, 11. Minus 4 plus 6, 10 plus 2, 12. So it is 11 minus 12, that is minus 1. So this number also is not divisible by 11. C option. It is 3, 1, 5, 6, 2, 4. 3 plus 5, 8 plus 2, 10. 1 plus 6, 7 plus 4, 11. So 10 minus 11 is minus 1. So this also is not divisible by 11. D option. 4, 1, 5, 6, 2, 4. 4 plus 5, 9 plus 2, 11. 1 plus 6, 7 plus 4, 11. So 11 minus 11 is 0. So this number is divisible by 11 because the outcome is 0. So the answer of this question is option D. All right. Now let's take question number 38. It says, which of the following number is divisible by 24? Now see, 24 is divisible by 3 and 8. Also, it is divisible by 3 and 2 and 4. So let's check the options. First option is 3, 5, 7, 1, 8. Now, divisibility test for 3 is sum of digits. Divisibility test for 2 is the last digit. And divisibility test for 4 is the last 2 digits. Divisibility test for 8 is last 3 digits. Now, for a number to be divisible by 8, it must be divisible by 4. Now, first option is there wrong there itself because in the end it has 18, which is not divisible by 4. So it cannot be divisible by 8, hence it cannot be divisible by 24. Second option, 6, 3, 8, 1, 0. The last 2 digits, it is 10. It is not divisible by 4, so it cannot be divisible by 8, hence it cannot be divisible by 24. Third option, 5, 3, 7, 8, 0, 4. Now here the last 2 digits are 0, 4. Hence it is divisible by 4. But now we need to check for 8. For 8, the divisibility test is last 3 digits, that is 804. Now we need to check whether 804 is divisible by 8 or not. Now you see, 804 is 800 plus 4. Now 800 is divisible by 8, but 4 is not divisible by 8. Hence the sum will also not be divisible by 8. So this number cannot be divisible by 24. Now D option, that is 3, 1, 2, 5, 7, 3, 6. Right? First check whether the last 3 digits are divisible by 8 or not. 736 can be written as 720 plus 16. As you can see, 8 9s are 72 and 8 2s are 16. So this number is divisible by 8. But now we need to check for 3. For 3 we need to add the digits. So 3 plus 1, 4 plus 2, 6 plus 5, 11 plus 7, 18 plus 3, 21 plus 6, 27. So sum is 27. Sum of digits is 27. So this number is divisible by 3 also. Hence this number is divisible by 24. 3 into 8, that is 24. So the answer of this question is equal to D option. Right? You can't go without checking completely. Alright? Now, question number 39. The question says, which of the following numbers does not divide 503880? Question is, which of the following does not divide 503880? Now, option A, it is 5. Very clearly, the number has 0 in the end, so it is divisible by 5. So 5 cannot be the answer. Option B, let's see. Option B is 7. For 7, I think it is better if you divide. If you divide by 7, what will happen? 7 sevens is 49. You know, if I am using the normal conventional method of division, 7 sevens is 49. Okay. So we have subtract 1, 3. 7 ones are 7, subtract 6. Then we have 8. 7 nines are 63. Subtract 5. Then we have 8. 7 8s are 56. All right. So this number is not going to be divisible by 7. So 7 is the answer of this question because it says which one does not divide. Further, we don't need to go and check, right? Because there is none of these. There are only 4 options. So 7 is the answer of this question, right? Because 7 does not divide this given number. So option B is the answer. 7 does not divide it. Alright, so we don't need to check further. Now let's take up question number 40. It says, which of the following numbers is divisible by 77? Now you see 77 is 7 into 11. So it's easier to check the divisibility by 11. So first we'll check for 11. Let's say option A. We'll have to check options. So 1771. If you take the sum of odd digits and sum of even digits, even place digits, it is 1 plus 7, that is 8, minus 7 plus 1 is 8, 0. So this number is divisible by 11. And for 7 you need to divide and check. So 1771, if you divide by 7, it will be 7 2s are 14, minus, so it is 37, 7 5s are 35, so it is 21 is divisible by 7. So this number is also divisible by 7. So A is divisible by both. But here if you look at the options, there is one option which says all of the above. So at least one more checking has to be done, right? Now B option, 2233. You don't need to check by 11 because it is visibly divisible by 11. Why? 22 is 11 double, 33 is 11 triple. So it is already divisible by 11. Now to check by 7, divide and check. Now 2233 divide by 7, 7 3s are 21, subtract, so it is 130, 13, 7 1s are 7, subtract, you get 6 3, 6 7 9. So it is divisible by 7 also. 7 9 is 63. Alright, so both A and B options are divisible by 77. That means, and there is no option which says only A and B. That means A, all of the above has to be the answer. You don't need to check the third option, right? See, please understand. Either A will be the answer, or B will be the answer, or C will be the answer, or D will be the answer. Here we are checking and getting both A and B to be divisible by 77. So without checking, C also has to be the answer because there is only one option satisfying this whole situation, that is all of the above. Okay, but if you wish to check, you can check C option as well. Let's say 2695. Is it divisible by 11? 2 plus 9 is 11 and 6 plus 5 is 11. So 11 minus 11 is 0. So it is divisible by 11. What about 7? Let's say 2695 divide by 7. So if you have 7 3s are 21, subtract, you will get 5, 59, 7 8s are 56. So it is minus 3 and 5, 35, 7 5s are 35. So it is divisible by 7 also. So all the three options are divisible by 7 and 11 both, hence by 77. So the answer of this question, I'll write here, answer of this question is option D, all of the above. Alright, be careful in marking your answers and in reading the questions. Okay. Now question number 41. It says, which of the following numbers is divisible by 66? You see, 66 is 2 into 3 into 11. So the number has to be divisible by 2. Here you can see all the options are divisible by 2 because they are all even numbers. I'll write the numbers. A option is 1514. Is it divisible by 2? Yes. Is it divisible by 3? Check the sum of digits. 1 plus 5, 6 plus 1, 7 plus 4, 11. Sum is 11. So it is not divisible by 3. Hence there is no point in checking for 11. B option, 1516. It is even number, so divisible by 2. Check divisibility by 3 by adding the digits. 1 plus 5, 6 plus 1, 7 plus 6, 13 is not divisible by 3. There is no point in checking for 11. Then C option is 1518. It is even number, so divisible by 2. It is 1518, so divisible by 3. And now check for 11. So 1 plus 1 is 2. 5 plus 8 is 13. 2 minus 13 is minus 11, which is divisible by 11. So C option is divisible by all of 2, 3 and 11. Hence it is divisible by 66. So the answer is C option. You can check for D also, 1520. This is divisible by 2. 1 plus 5, 6 plus 2, 8 is not divisible by 3. So the answer of this question would be C option. That is 1518. Okay. Now let's say question number 42. It says if the product 4864 into 9p2 is divisible by 12, then the value of p is. Now first divide it by 12. Let's see what happens. Now 4864 is divisible by 4. 12 is also divisible by 4. So divide by 4. So if you divide by 4, you get 3. And here 4864, if you divide by 4, it will be 12, 16. Now 1216 is not divisible by 3. Right? Check it. 1 plus 2, 3 plus 1, 4 plus 6. That is 10 is not divisible by 3. That means 9p2 has to be divisible by 3. Alright? So check the sum of digits of 9p2. 9 plus p plus 2, that is sum of digits will be 11 plus p. Now this has to be divisible by 3. Now for this to be divisible by 3, the nearest value will be either 12, or you can go further, 15 or 18, alright, or 21 and so on. No, 21 you can't take because in that case p will be 10. Now for these cases, if it is 12, p will be equal to 1. If it is 15, p will be equal to 4. If it is 18, p will be equal to 7 and so on. Right? Now out of these values 1, 4 and 7, if you look at the options, there is no option given. Alright? There is no option given. Now what does it mean? It means the answer would be none of these, because options are 2, 5, 6 and 8 and none of these. So answer of this question would be none of these, that is D option. Alright. Now let's take question number 43. It's a very beautiful question. It says a 3-digit number 4A3. A 3-digit number 4A3 is added to another 3-digit number 984 to give a 4-digit number 13B7. And this 13B7 is divisible by 11. So let's first find the value of B. How do we do that? We add the digits 1 plus B and 3 plus 7. So 1 plus B minus 3 plus 7 should be either 0 or divisible by 11 or minus 11, whatever. Right? So let's check it first. So it is 1 plus B minus 10, which is either 0 or 11 or minus 11 and so on. So it is B minus 9 has to be either 0 or 11 or minus 11 and so on. By checking you can see that only 0 will satisfy, because if I take B minus 9 to be 0, B will be equal to 9. If I take B minus 9 to be 11, then B will be 20. So I can't take 11 and beyond 11 also. Similarly, if I take B minus 9 to be minus 11, B will be negative, minus 2. So there is only one value possible, that is B equal to 9. Right? Now let's put 9 in place of B and write the question again. So it is 4A3 984 and on addition we get 1397. So we already have 3 plus 4 as 7 and there is no carry forward. So A plus 8 has to be 9. So A has to be 1. Here A plus 8 has to be 9. A plus 8 has to be 9. So A has to be equal to 1. So we have the value of A as 1, value of B as 9. The question is asking A plus B, that is 1 plus 9, which is 10. So the answer of the question is 10. Alright. Now let's take up the next question, question number 44. It says how many of the following numbers are divisible by 3 but not by 9? Let's take one by one. 2, 1, 3, 3. Simply add the sum of digits, simply add the digits and find the sum. So 2, 1, 3, 3, or let's do that for every number. The sum will be 2 plus 1 plus 3 plus 3, that is 6 and 2, 8 and 1, 9. So this number is divisible by both 3 and 9. So this cannot be the answer. Next number is 2, 3, 4, 3. Add the digits. 2 plus 3, 5 plus 4, 9 plus 3, 12. This number is divisible by 3, but not by 9. So this can be our answer. See, 12 is divisible by 3. So the number is divisible by 3. 12 is not divisible by 9. So the number is not divisible by 9. And that satisfies our condition. We have to find the number, find all those numbers which are divisible by 3 but not by 9. Right? Okay. Similarly, the next one, that is 3, 4, 7, 4. Add the digits. 3 plus 4, 7 plus 7, 14 plus 4, that is 18. Now 18 is divisible by both 3 and 9. So the number is also divisible by both 3 and 9. So this cannot be our answer. Alright. So go on striking out the not correct one. So 4131 is the next number. The sum of digits will be 4 plus 1, 5 plus 3, 8 plus 1, 9. 9, that means divisible by both 9 and 3. So this cannot be our answer. Then the next one is 5286. Go on doing that for every number. 5 plus 2, 7 plus 8, 15 plus 6, 21. 21 is divisible by 3 but not by 9. So the number is divisible by 3 but not by 9. So this will be counted for our answer. Next number is 5340. 5 plus 3, 8 plus 4, 12 plus 0 is 12. 12 again is divisible by 3 but not by 9. So this has to be counted. Then we have 6336. If you add, you get 6 plus 3, 9 plus 3, 12 plus 6, 18. This is again divisible by both 3 and 9, so do not count it. Count only those numbers which are divisible by 3 but not by 9. 7, 3, 4, 7. Add them. 7 plus 3 is 10 plus 4. 14 plus 7, 21. Right? 21 is divisible by 3 but not by 9. So count it as your answer. Then 8, 1, 1, 5. 8 plus 1, 9 plus 1, 10 plus 5, 15. 15 is divisible by 3 but not by 9. So we have to count it. Then 9, 2, 7, 6. 9 plus 2, 11 plus 7, 18 plus 6, 24. This again is divisible by 3 but not by 9. This also must be counted as our answer. Alright, so now let's check how many we have ticked out, or how many we have ticked as correct ones. Let's see. 2, 3, 4, 3 is one. This one. Then we have 5, 2, 8, 6, this one. Two numbers. 5, 3, 4, 0 is the third number. Then 7, 3, 4, 7 is the fourth number. 8, 1, 1, 5 is fifth number. 9, 2, 7, 6 is the sixth number. So the answer of this question is 6. Answer is 6. That is option B, as you can see. Now let's take the next question, question number 45. It says, how many of the following numbers are divisible by 132? First check 132. 132 is 12 into 11. That is 3 into 4 into 11. So whatever number we are going to check, that has to be divisible by each one of those numbers, that is 3, 4 and 11. Now the first number is 264. 264. Is it divisible by 3? In fact, if you look at it closely, it is 132 ka double, that is 264. Or let's check it one by one. So is it divisible by 3? 2 plus 6, 8 plus 4, 12. So it is divisible by 3. Is it divisible by 4? The last two digits 64. So it is divisible by 4. Is it divisible by 11? 2 plus 4, 6 minus 6, 0. So it is divisible by 11. So 264 is one of the correct answers. Next option, that is 396. Is it divisible by 3? All the digits are multiple of 3. So it has to be divisible by 3. Last two digits 96. It is divisible by 4. So it is 4. And for 11, add 3 plus 6, 9 minus 9, 0. So this also has to be counted as the correct answer because it is divisible by 11. Now let's take 462. Is it divisible by 3? 4 plus 6, 10 plus 2, 12. Yes. Is it divisible by 4? Last two digits 62. So it is not divisible by 4. So this cannot be counted as our answer. Right? 62 last two digits is not divisible by 4. So leave it. Then the next number, 792. Let's consider it. Is it divisible by 3? 7 plus 9, 16 plus 2, 18. So it is divisible by 3. Is it divisible by 4? 92. Last two digits 92 is divisible by 4. So the number is divisible by 4. Is it divisible by 11? So 7 plus 2 is 9. Minus 9 is 0. So the number is divisible by 11. So this also has to be counted as the correct answer. Then next number is 968. Let's check. Is it divisible by 3? 9 plus 6, 15 plus 8 is 23. Oh, so it's not divisible by 3 itself. So finished. You don't need to check further for 4 and 11. Then we have next number is 2178. 2178. Check the sum of digits. So 2 plus 1, 3 plus 1, 7, 10 plus 8, 18. Is it divisible by 3? Yes. Is it divisible by 4? Last two digits 78. Not divisible by 4. Right. So you don't need to go further. This cannot be our answer. Then we have the next number as 5184. Now 5184, let's check. Is it divisible by 3? 5 plus 1, 6 plus 8. 14 plus 4, 18. Yes, it is divisible by 3. For 4, check the last two digits. 84. Clearly divisible by 4. Yes. Now for 11, 5 plus 8 is 13. 1 plus 4 is 9. 13 minus 4 is 1 plus 4 is 4. Sorry. 5 plus 8 is 13. 1 plus 4 is 4. 13 minus 4 is 9. So it is not divisible by 11. So this cannot be our answer. Now let's take the last number, that is 6336. Is it divisible by 3? Visibly all the digits are multiple of 3. So it is divisible by 3. 6336. Last two digits 36. So it is divisible by 4. For 11, check the sum of digits at odd places, sum of digits at even places. 9 minus 9, 0. So this number is divisible by 11. So our answers would be 264, yes. 396, yes, 2 numbers. 462, no. 792, yes, 3 numbers. 968, no. 2178, no. 5184, no. 6336, yes. So total 1, 2, 3, 4. So there are 4 such numbers, right? So our answer of the question would be 4, which is option A. Okay.